So this is lesson 1.1a, identifying arithmetic sequences. This is the first lesson for the sequences and series unit. So we need to figure out the language that they're using. So for example, a sequence is a list of numbers separated by commas. So this is the most basic sequence that we're used to. The first term, meaning the first number in the sequence, is always labeled as term 1. And then so on. So this is term 2, term 3, term 4, term 5. Let's say I want to find a certain term within the sequence. I would say Tn. So that could represent an unknown term within the sequence. So I could say that, let's say I want to find term 100. I could then, I would have to find out what is in the 100th spot. So this represents your spot. What spot are you in? We call Tn our general term. So we use that for our equations. So example number 1, they're giving us a sequence of numbers. They're giving us 3 terms. So each of these separated by comma is a term. So T1 is -5. T2 is -1. And T3 is 3. They're asking us to solve for term 5. So what we could do is figure out what the common difference is. The common difference means, what am I doing to go from one term to the next? So how am I going from -5 to -1? So what you can do to find the common difference is you can take term 2 minus term 1. Or it would also work if you did term 3 minus term 2. So for example, if I took 3 subtract -1, I would get that the common difference, meaning what I'm adding to go from term to term, is the number 4. So from -5 to -1, I added 4. From -1 to 3, I added 4. And if I keep doing that, I'm going to get to the next term. So we can use that to solve for term 4. So that would be 3 plus your common difference. So that would be 7. And then term 5 would be 7 plus your common difference, which is 11. So that's our answer for term 5. Now there's another strategy to find out terms. There's a general term equation that can be found on your formula sheet. So Tn is actually equal to your term 1 plus n minus 1 times your common difference. So your term 1 is the first term of the sequence, which we know is -5. Plus your n is, what spot are you talking about? I'm talking about spot 10 because it's term 10 that I need to solve for. So that little number is always your n. So 10 minus 1. And our common difference is the letter D. So we know that it is already 4. So we have -5 plus 9 times 4. We have to do BEDMAS if we're doing this properly. -5 plus, we have 36, and then -5 plus 36 is actually equal to 31. So that is our term 10. Example number 2, they're giving us Halley's Comet. So if you were to subtract term 2 and term 1, you would actually get that the common difference is 76 at first. And then if you took term 3 and term 2, it's adding 75. And then term 3 to term 4, you're adding 76. So this is not a real arithmetic sequence. An arithmetic sequence is when you're adding the same number each time. So this one, it's an approximate one because the common difference changes. But what we can do is we can approximate when we're going to see Halley's Comet by adding. If we keep adding a number like 76 each time, so if I keep adding 76, so if I take 1758, the year 1758, and add 76, so I'm picking between either 75 or 76 to use them as my common difference. And if I keep doing that until it's a year that we know, we can approximate when we're going to see Halley's Comet. So we're going to see Halley's Comet in approximately 1834, approximately 1910, 1986. And then we're saying that approximately in the year 2062 is the next time you guys would see Halley's Comet. Okay, so these are just ways of using the arithmetic sequence in nature, even though it might not be fully accurate. It's going to give us a range of years if we use 75 all the way to 76 years as the common difference. Example number 3. We know that to go from term 1 to term 2, we would find the common difference. So the common difference would be 2x plus 8, which is term 2, subtract term 1. So we're subtracting 6 from that. So the common difference can be simplified as 2x plus 2. So as you can see, we have two unknowns, which means we need two equations. So there's one equation, but we need to create another one. And we can do that by taking term 3 and subtracting term 2. So term 3 was 6x minus 4. And we're going to subtract in brackets 2x plus 8. Whenever there's more than one item, we need to put brackets around it because the negative needs to distribute properly. So this is distribution properly done, and this will equal d as well. So d is equal to 6x minus 2x. We're going to combine like terms, and negative 4 minus 8 is negative 12. So as you can see, I have two linear equations, which I'm going to use a process of elimination or substitution. So this is going back to like 10C and what we did in the sequences, the systems of equations unit, where we can use either substitution or elimination. So elimination is where you line them up. And what I'm going to do is subtract them, and you'll see that the d minus d will become 0. And then 2x minus 4x is negative 2x, and 2 plus 12, because the two minuses become positive 12, will become plus 14. Now we're going to bring this to the other side so that we can solve for x, which means that 2x equals 14, and then we can divide by 2 on each side to get that x is equal to 7. So we just found what our value of x was. That was for a. Now they want us to find the value of each of the terms. Well, we know that term 1 is already 6. Term 2 is by placing x as 7. So term 2 will be 22. 14 plus 8, which is 22. Term 3 will be 6 times 7 minus 4, and that would be 38. So these are the first three terms of the sequence. Our common difference can be found by using either this equation or that equation, where 2 times 7 plus 2 will equal the common difference, and that common difference is 16. So we just found all the necessary pieces to create and continue our sequence if they asked for it. So in example number 4, term 1 is negative 4. So what is in the first spot? What is in the second spot? What is in the third spot? What is in the fourth spot? And what is in the sixth spot? So they want us to plot these values onto our graph here. So we'll start with terms going at the bottom. So this will be our term number versus our value of the term will be our y's. So we'll go from negative 4, 0, positive 4, 8, 12, 16, and up to 20. So we know that term 1, we're going to be at negative 4. Term 2, we're going to be at 1. Term 3, we're at 6. Term 4, we're at 11. And term 5, we're at 16. So if you look, this creates a linear graph. So if we were to connect these, if we're doing this properly, an arithmetic sequence, which is what we have above, should always equal a linear graph. So if we were to ever graph it, we always get that straight diagonal line, which is linear. Okay. And so things that you want to summarize from this lesson is that the terms represent what spot, what you're in, or where you're at in the sequence. So if you're talking about term 3, that's the third spot. What is in the third spot of the sequence? Okay, arithmetic, you should always be adding either a positive or negative value to get from term to term. So in 1.1b, which is a continuation of this first kind of idea, this one is arithmetic because we're adding the common difference of 3 to get from term to term. This one is arithmetic because you're adding -5. You can add a negative or a positive value to go from one term to the next. These two are not arithmetic because they are multiplying to get from one term to the next. And this one is adding as well because you're adding a common difference of 2 to go from term to term. So only when you add a constant will it create an arithmetic sequence. So term 20, we can use the equation which is Tn equals T1 plus n minus 1d, and this will give us any term within the sequence. So they're giving us a sequence of -3, 2, 7, and 12. Term 1 is always the first number in your sequence. The common difference can be found by taking term 2 minus term 1, or any terms that are side by side, you could subtract them. So 2 take away -3 is going to actually equal 5. And our n in this case is 20 because that corresponds to the little number that they're asking for. So term 20 will equal our first term plus n, which is 20, subtract 1 times our common difference of 5. So if you put this into your calculator or follow BEDMAS properly, you should get that the term 20 is 92. So in the 20th spot, you should see the number 92 if you were to continue the sequence. Now they're saying, which value of the sequence has the value of 212? Well, that's our general term. They're saying this is what's in the spot. They want to know what spot is it. So we don't know our n value. So we're going to solve for that. So Tn in our equation will be 212. So again, we're using the same equation with 212 replacing our Tn. Our first term is still -3. Our n we need to solve for, and our common difference doesn't change. It's still 5. So what I would do is I would distribute this 5 into the brackets to get that 212 equals -3 plus 5n minus 5. Then I can add 3 to this side and this side to get rid of it, and add 5 to bring the -5 and the -3 to the other side. So that's going to give me 212 plus 3 is 215, and then 220 equals 5n. So 220 divided by 5 is how we're going to solve for our n value. And n is equal to 44. So that is what spot we're in when the term is 212. Now 246 is not a term because if I look at solving for my n value, if I put 246 into my Tn with T1 as -3 and n being solved for, you're going to solve that the n value is approximately 50.8. Well, it'll be exactly 50.8. Now, n is not allowed to be decimals. N can only be a whole number. Because we can't have a number in the 50.8th spot. That wouldn't make sense. We can only have numbers in the 50th spot or 51st spot. So there is no in between in a sequence, so this one can't exist. We can't have decimal values, so only whole numbers are allowed for n. Otherwise, it might be allowed in a real life scenario, but not here, where it's just a sequence of numbers. In this next one, or in the same one, we know that term 1 is equal to -3, term 2 is 2, 7, and 12. So when we're creating our equation, remember we're taking our -3 value, and we're taking -3 plus 1 times our common difference. So in this case, to go from -3 to 2, we had to multiply by 5. So if you guys put that into your calculator, you'll see that that's what gives you. So this first one is just T1 plus 0 times your common difference. So this is the pattern that we use to create the equation. This one's going to be term 1 plus 1 common difference. So since our common difference is 5, we're actually multiplying or adding 4 to get to that value, because it's 1 less than our common difference. So we're multiplying by 1 for this one. In the next case, we're multiplying by 2 times our common differences. So it's always 1 less than the term number. If we're on term 3, we're adding 2 sets of these common differences. If we're on term 4, we're multiplying 3 times 5 and adding that to our first term. So as you can see, there's a pattern that's formed. And that's how they created that general term equation. So our equation where T1 always represents our first term, N is your spot. What spot are you in? D is your common difference. What are you adding to get from term to term? So it can be a positive or negative number. And this is called your general term. So in this next case, in this next example, they're not giving us term 1 and they're not giving us term 2. They're giving us term 3. Well, what we can do is we can say, well, term 3, how many common differences would we have to add to get to term 8? Well, I can make that list here. So I would have to add 1 common difference to get to term 4, 2, 3, 4, and 5 common differences to get to term 8. So I create this kind of equation here, which helps me because now I can replace term 3 with 4 and term 8 with 34. And this is a quick way of solving for the common difference. So I can subtract 4 on both sides to get 5d is equal to 30. And then divide by 5 on both sides to find that the common difference is 6. They want to know what term 20 is. Well, we still need to find out what T1 is. So we can go to the equation now where we use this point or the other one. We know that Tn equals T1 plus n minus 1d. When Tn is 4, we know that the n value, the spot that we're in, is 3 times your common difference, which is what we just found. So that will be 4 equals T1 plus 3 minus 1 is 2. 2 times 6 is 12. We're going to subtract 12 on both sides and get that T1 is actually equal to -8. So these are 2 pieces of information that we need to solve for term 20. So term 20 will actually equal term 1 plus 20 minus 1 times your common difference, which is 6. So -8 plus 19 times 6 gives us, if we put that into our calculator, 106. So that's our final answer. So we had to find term 1 and our common difference before we could have solved for our term 20. Example number 3, they want us to write a general term equation. So we're going to fill in what we can into this without knowing how many hours have been worked in this situation. So our first term is, we know that we're getting $13 per hour. This contractor has been hired for $13, so we're going to put T1 is 13. And we don't know how many hours he's worked, But we know to go from 13 to 21, we would have to multiply, or we would have to, when we subtract the values, we get a common difference of 8. So our general term equation is just filling in what things don't change and leaving the rest. So we're going to distribute the 8 in. And 13 minus 8 gives us 5. So it's going to be 8n plus 5. So the reason we write it this way is because then it's simpler to substitute values into it, and it's actually a linear equation. So we're going to replace n now with 6 because we know how many hours have been worked. So T6 is what we're trying to solve for. So 8 times 6 plus 5, we're using the general term equation here. 8 times 6 plus 5, if you put that in your calculator, equals $53. So that's how much he earns for 6 hours of work. Example number 4, they're giving us that they're giving us the ant population. So we know it's arithmetic. So we know that the population is increasing by approximately 80 ants. So D equals 80. We know that beginning with 40 ants, meaning our first term is 40 ants. And they're saying, when will the population reach 3,000? So that's our Tn value. So this is what it's looking like. 40 plus, if I add 80, I'm going to get 120. If I add another 80, I'll get to 200. And we want to find out, when is it going to be 3,000 as a population? So we're going to use the general term equation for arithmetic sequences, where it's Tn, which is at 3,000, equals our first term, T1, plus n minus 1 times D. Common difference is 80. So we're going to solve for n by subtracting 40 on both sides. So that's going to give us 2,060 equals, we can distribute the 80 into the brackets. So that's one technique. Add 80 to both sides. And we get that it is equal to 3,040 for 80n. Lastly, divide both sides by 80. And we get that n is equal to 38. We know that this is going to take, we're talking about the number of months that's going to take. So this is 38 months as our answer. Okay, so include time if they give you that in the question. Example number 5, they're giving us that in the 8th row, so in term 8, we have 14 cans. And then in the 12th row, meaning term 12, we have 10 cans. So what we want to do is write an equation for both of these. So this is another technique that we can use, or we can do that same question, same kind of idea as previously, where we go term 8 plus, we're saying to go from term 8 to term 12, we would have to add 4 common differences to get to term 12. So that would be one technique to do this. Or what you can do is write an equation where 14 equals term 1 plus n, which is 8 minus 1 times your common difference, which we don't know. And we would do the same for the next one. 10 is equal to the first term plus the spot number 12 minus 1 times your common difference. So we're filling in into our general equation what we have, and we don't know our term 1 or our common difference, so we leave those blank. And then we're going to simplify this. 14 equals T1 plus 7D, and this one's going to be 10 equals term 1 plus 11D. So this is where we can use elimination again to subtract these equations and then get rid of one of the variables. So 14 minus 10 is 4. T1 minus T1 is 0, gone. 7D minus 11D is negative 4D. Divide both sides by negative 4. D, your common difference, is actually equal to negative 1. This sequence is going down. You're taking out a can for each row that you continue on. So once you find your common difference, you can use one of the equations that you previously used, which is this one, and substitute d as -1 to solve for the other one. This is called substitution. So I'm plugging in -1 into d, and I get 14 equals term 1 minus 7. So I'm going to add 7 to both sides and get that term 1 equals 21. So far I found my common difference, my first term, and the general term equation that I would use to rewrite this would be 21 for your common or for your t1 plus n minus 1 times -1. Simplify this. Distribute the -1 into the brackets. You get -n plus 1, which means that 21 plus 1 is 22 minus n. This is your general term equation, where you could replace n and then solve very easily for tn. So in this exit task, they're asking which arithmetic sequences contain the term 34. So what you would do is replace tn with 34 and solve for the n that is a whole number. So if you get that n is not if n is not a whole number, it is not in the sequence. So for example, b, if I go 34 equals 3n minus 1, I would add 1 to both sides. 35 divided by 3 will not give us a whole number, so it can't be b. And then here, if we were to continue this sequence, it wouldn't give us 34. And same for C. The only one that works is if we replace Tn with 34 and solve for n in question A. So I would subtract 6 on both sides. That would give me 28 equals n minus 1 times 4. A step that you can always do is you can divide both sides by 4, which gives us 28 divided by 4 is 7. So 7 equals n minus 1, and then you would add 1 to get that. You're at term 8. So that would be a whole number, which means that that term 34 would be in the sequence. So that is lesson 1.1a and 1.1.